Box, der vil fortælle dig om precipitation på Grønland, nedbør på Grønland, og på indlandsisen og på glacier. Og efter foredraget, så vil der være mælk og æbleskiver og øl, hvis man vil have. Og så starter anden del, der vil bestå af en quiz. Og så vil der blive en oversigt, og vi skal se, om vi kommer til jul. Martin Lindberg fra DRI vil komme og give sit bud på det. Du er her. Godt. Og så vil Henrik Rødborg var inviteret, men kan desværre ikke komme. Han har set sit bud på det. Og jeg ved ikke, om vi får fat i ham over Skype eller på en eller anden måde, men han kan i hvert fald se noget skriftet materiale. Så det er det. Og så er jeg
Hello, everyone. Welcome to GAEUS. It's a real pleasure to help host this meeting, the Julemøde. I hope that it's okay. I'm presenting in English, and I've been here for a few years. I think it's useful to tell you a little background. My previous life, I was a university instructor for 9 years, instructing boundary layer climatology and instrumentation in microclimatology. And I've been working on Greenland for quite some time, and that is why I ended up in Denmark. And I'm happy to share with you this interesting question: how much rain falls in Greenland? You can see the DMI observing stations around Greenland. This very recent study from this year, they are comparing the so-called Arctic System Reanalysis, that is the Polar MM5 regional climate model, in a 3D VAR data assimilation, and it looks like a pretty okay result. You know, I think you know how heterogeneous precipitation is spatially, and so you know, hats off to them for making this detailed comparison. Coastal stations. John Kaplan and I were recently discussing the challenge of accurate precipitation measurements in windy environment. I look forward to talking offline after this about all of the precipitation that Denmark has been getting in the last year. I hear it might be a record rainfall year, so very interesting. And another study, oops, that I led this study something like 15 years ago, using the same model, earlier version, made a map of Greenland precipitation. And there was a lot of very interesting stuff here, like mesoscale kind of dry spot where you would expect it near here in this continental part of Greenland. Extremely high precipitation rates, as you know, along the southeast. Factor of 100 less precipitation in the northeast, so huge regional patterns. The model here gets this offshore intensification of the precipitation. That was interesting. The orographic high, you can see these green colors where there's more precipitation on the inland ice, so also super interesting. And the question of how much rain and snow falls on the inland ice is a big question, because a lot of the ice cores, they are taken quite high on the inland ice, and down low and on the margin there's few cores taken, and so the question of how accurate the models are in the steep part of the topography is an important question. And And Ruth helped with this one some years ago. And so here we have the days of the year, 2 different time periods, 89 to 01 and 02 to 12. And this is okay temperature. And on the top you see the fraction of the total precipitation that is rain.
Where is this from?
This is from the so-called K transect in along the west. So the K transect is just below the polar circle right here. Yeah, and please interrupt with other questions if that something is not totally clear. Yeah, so that's this. It's an elevation profile on the inland ice going up to, I think, yeah, the elevation is given here. And so in this case, that's at an elevation of 1,500 meters. And these 2 different time periods, you can see in the later period, it's divided in half. You see a warmer climate almost throughout the whole year. And then the rain fraction on the top is about the same at that elevation. So we're just going to go higher or lower and lower in elevation. So now we're going to 1440 meters, and you'll notice these temperatures are going to start to hit the melting point as we go lower in elevation. So lower again. The rain fraction is kind of the same again for these 2 different time periods. Now we're going lower in elevation. And what was fascinating to see here reproduced by the Hirham model was the rain fraction of precipitation really starting to separate itself from the earlier period, suggesting the kind of, now we're going back high again, let's go low, and you see the rain fraction of precipitation getting larger. Not really a surprise. You would hope that the regional model would get this in a warmer climate, more rain instead of snow. It's like my daughter was complaining to me this morning, Dada, why is it there's not snow on the ground in Uhltil? And that's when I said, well, remember the extra carbon dioxide in the atmosphere that I was telling you about every day that I can? So it's quite sad when your kid wants to go sledding and there isn't snow. And that's kind of the story that these data tell. So on Greenland, we're very fortunate that the Danish state is supporting these automatic weather stations. Nice photo when it's all nice and level. And you can see this equipment, the tower, the measurement frame is kind of overloaded with measurements. You can see the radiometer there, number 1, tilt sensor, etc. It's got the kind of the meteorological equipment to do the bulk method for the turbulent heat fluxes. But I don't see a precipitation gauge on the station. And that's something that I started complaining about, and eventually convinced the conservative meteorologists here to put this toy rain gauge on the station. And you know, they really gave me a hard time about this. So even they're like, they wouldn't let me attach a pulse counting rain gauge. I had to use a self-logging rain gauge. But I, anyway, just started doing this on these weather stations. And so now you can see the rain gauge that I attached near the top of this equipment. Another nice photo when the station is nice and level. Here's just another shot here of the rain gauge, kind of like the parasite on the weather station. And so I've managed to put these gauges on these 4 locations down here on the Casimir lobe of the ice sheet. And then a couple of them here on the K transect. Yeah. Very good. And so here is the kind of inventory. Dirk set up one of these at Camp B in West Greenland. Here are the kind of 4 on the Casimir lobe. And so this whole started really in August of 2016. So now we have already 3 years of data. The instrument's it has stayed alive. So it just has a little, battery. And so I got into the obvious question about the undercatch of the instrument, and then using the Hellman type correction factor. This is actually the wind speed measurements from one of these sites. You can see that this is where most of the data is. It's about 4 meters per second wind speed. And then the unshielded versus shielded, the catch efficiency. You can see it's only catching about half of the raindrops according to this relationship. And then the shielded, of course, higher catch efficiency. And so the ratio of these 2 lines is this K factor that the uncorrected are then divided by to boost the uncorrected measurements. And that produces a result like this, where effectively you're doubling the rain. So a huge correction. Yes, it's uncertain. Let's hope. Come in, full.
Thank you.
Let's hope that the correction is improving the results. If you believe the correction, the total precipitation is more than 2 meters. And that's actually more than the water equivalents that we measured in the snow. So at this location, it's quite low on the inland ice. There's 3 times as much rain as there is snow, according to our end of winter snow pits. So rain is common, especially in the southern Greenland ice sheet here. Start to become fascinated by this question of gauge correction, and then the overachieving Tretyakov fence. It's a double fence. And the also very proud double altar screen on it with a Geonor gauge. Pretty nice. I've been bugging the people at Geonor, asking them for a double screen quote, and they say they don't make them. So, but they do sell the single shield gauge, and our Swedish friends collaborating at one of these locations have set this guy up. Also back in 2011, they set this thing up. You can see the single altar shield next to the Promise type weather station. And that, in 2016, Dirk put the hobo gauge on the station. And so we actually have a few months of intercomparison. And so this morning, this was what I spent the morning on doing, is getting the co-located hobo and corrected undercatch and adhesion corrected Geonor precipitation. These are daily totals, and the result is it's not that bad, if you ask me. What you then start to see is that the tipping gauge mechanism in the hobo isn't tipping when there's trace precipitation. Not really surprising. So there's definitely an undercatch just on the trace precipitation. What I want to do is actually, I want to add up these Geonor, when the Geonor is working, because it's a vibrating wire. It weighs the fluid inside the the bucket. And, you know, I'm curious now, I didn't have time for it, but I want to add up these guys. Do these trace precipitation, do they add up to much? Do they add up to much fraction of the total? I don't know. I kind of hope that they don't, because then maybe the hobo, the simple unheated tipping bucket gauge is not totally, how do you say, garbage. But you know, that's this result. Now here is with the catch efficiency correction. In the blue dots, you can see that shifts the hobo data this way, and you actually get closer to the line, maybe. There was one point here that jumps off the screen. I think it's this guy, because you'll notice that each point just kind of moves this way, but this guy, for some reason, I think it must have been very windy at that moment, because it is, now the scale goes out to 14 millimeters, and that's this guy up here. It is what it is. I think this is maybe my last slide here, which is, in this comparison, we have 23 precip days above zero when both recordings are above zero. The average differs by 11%. And if well, did I do that? No, I took it off. If I exclude that outlier, then it's 5%, but I shouldn't exclude the outlier. So I'm kind of encouraged by this result, because we want to validate the regional climate model so that we can look more confidently at precipitation on the Greenland ice sheet. So hope that was scientaining for you, and look forward to difficult questions. This only rain. In fact, that's the plan. We found a Nunatak, and it's not so high, but it's along the Q transect, so it's at elevation between the lower and the middle site, and we're trying to get the new ERC Synergy project Deep Purple to pay for it.
And the Q's transect, that's way up in the northwest, right?
The Q is for the Casimir, that's the
so it's
sky
down
in the
south.
south.
Okay.
Yeah, so this kind of Nunatak is right there. And, you know, there's relatively more rain there. But rain has been observed in North Greenland, I guess, as many of you know.
You are all looking into the old observations made by Geus in the 1980s, because at that time there were at least 3 stations along the west coast.
Measuring rain.
Measuring rain, measuring snow, having separate cans next to each other, trying to figure it, and so with screens as well.
Should I ring Roger Braithwaite, or?
He was very much involved in that. But
Dare
all the data was a bit...
Dare I ring Roger Braithwaite? No, that would be fantastic. That's an excellent point.
Because a lot of knowledge to be gained from that before you start spending too much money on this kind of observation equipment. You get a basic understanding of what these gauges catch. And even with a single fail or double fails, you will run into problems. And please use the information gathered. It was very cold when we took the observations.
So you were there.
I was there for 6 years, yes.
Holy cow. Can you tell us more?
Yeah, the project leader was Ole Olsen, but I think Roger Braithwaite was the guy in charge of the presentation measurements.
There were some extreme precipitation events, like the 17th of September 2017, where in Qaqortoq or Narsarsuaq, they're observing more than 100 millimeters of precipitation in one day. And so those are the events that we're probably going to focus on. Extreme, rain. Maybe the signal is so large that for that event, we don't have to worry so much about the technique working all of the time. But I'll look into the Gayers rain stuff.
Can you maybe go back to the other place where you had the elevation, where you looked at different elevation heights?
Yeah.
Because I didn't understand, or maybe it's a good question. How come the red line doesn't match up in December to January? Wouldn't we expect it to end near it's 0 in January and it's really high in December or late December? Didn't we expect it
The rain fraction of total precipitation.
Yeah.
So I think this means that it's mostly snow or only 20% rain in the cold months, but then 100% rain in the warmest periods of time.
Yeah, but in December is on the right.
Yeah, like that. This guy, or
Yeah. It just isn't it weird that that's not 0 when January is 0? Shouldn't they end the same?
well, there's this kind of running average, and so each day is really independent of the next, I think.
So it's a 10-day running average, so you're missing the last days there
It's
in
this
that it stops.
It's a Gaussian boxcar. I think, yeah.
Is it correct understood that it's a 11-year accumulated precipitation?
Let's see, yeah,
So you have a kind of 1 week in early January where it's not raining or snowing, and then suddenly you have a 2-week period?
Yeah, this would be kind of an 11-year climatology for that day. So just a way of averaging optimistically. But yeah,
If you look at the precipitation,
the rain fraction.
the rain fraction is sparse, isn't it? The blue, what is that? Is that the first period and the red is the second?
Yeah,
And what is the spark?
like which spike?
For example, the first one, pick one.
Like this guy?